So far, we've looked at compositing video and building 3D scenes with lighting and texturing. Now it's time to make things move. One way to give motion to our objects is using modifiers, which are data generators that you can use to drive null graph properties, including their position, rotation, size, and more. In fact, you can use modifiers for almost everything in Notch, not just motion. This chapter is another workshop, so as always, I encourage you to follow along and feel free to pause or rewind. Welcome back to the course. In this chapter we will talk about modifiers, but before we get started, let's make sure that the videos that we set out to use in this chapter are linked and ready for us. If yours are red, not orange like mine, do make sure to right click and go for Find Missing Resources, navigate to your Assets, Video folder, and just link them up. Right. With that done, we can start our conversation about modifiers. So modifiers are a great tools to make repetitive animations and build some math-based systems. If I go now to the node list, you will notice that we have abundance of them. There's great many. However, there are several that I would consider the main building blocks, and once you master those, all the rest comes fairly easy. So let's start by adding a 3D primitive. We will animate this 3D primitive with modifiers. I have grid enabled. If your screen is empty, I would strongly suggest to turn it on by hitting Alt G. So let's add a math modifier to the scene. So math modifier is a math function. It holds quite a few expressions in it, from sine to cosine, you name it, and it basically oscillates between two values. Like in this case, in sine is just the upper value and the lower value. Of course, there are more functions here, and they all have a good reason to exist and a lot of applications, but let's just stick around with the default now, sine. I can increase the scale, I can of course change the speed of it, and I can offset it in time. This all will make more sense when we're actually gonna hook up the modifier to some drivable property. So in order for me to use this math modifier to drive, let's say, position X value of the 3D primitive sphere, all I have to do is grab the output of the modifier and connect it to the property that I want to alter. And there we are. Now we are driving the position X of this 3D primitive with a math modifier. I will reduce the speed a little bit. There we go. A good telltale that there is a driver connected to a specific parameter is this yellow underline here, and as you see we have numeric values of what information is being given or taken by a modifier. Now 3D primitive has just one input by default, but as we add modifiers, the input list expands. So even if I unhook it, it's still going to be there available on this specific node because we already used it. If you're interested in seeing all of the properties that you can drive with modifiers, just double click on a node and you will see a vast list. Now it's a little bit extensive, and I don't think it's the best way to work with the node if you want to animate something. So I'm more accustomed to grabbing the output and connecting it to the property in the properties panel. That just makes life much easier. So we are not obliged to use one modifier to drive one specific value. We can use the same modifier to drive several values. For instance, I will connect this to the position Y. And now both position X and Y is being driven by the same math modifier. We can add an extra modifier and use it with the same sphere. So I will change this modifier's math function from sine to square. So this is more of an on-off function. And I think I will drive its position Z. There we go. It's definitely working. Perhaps it could be a little bit slower. I can use the same modifier to drive several 3D objects. So if I add one more 3D primitive, I can grab the newly made math modifier and connect it to this sphere's position Y. There we go. I will delete these nodes and I will make another example using another type of modifier. So first of all, I will start by adding a null. Now we're already familiar with a null from video processing. 3D World has null of its own. In this case, in 3D, null holds just the positional and rotational value. And this is a good opportunity to talk about parent-child relationships. So if I add a primitive, I can of course connect it to the root of the scene, but I can connect it to a null or another primitive as well. So I'll do that. So now the null is in the center of our graph, and so is this sphere. So I'm going to offset the sphere a little bit. So null is still there in the center, but the primitive is offset. So what that means is that when I'm driving the rotational value of the null, I'm actually driving that sphere as well. And that is because it's parented to the null. So this is a good opportunity for me to add a continuous modifier. Now, continuous modifier does exactly what the name stands for. It just continuously spits out information. So I'm going to connect it to the heading property. And as you see, it's moving our sphere by rotating this null on the heading. It's super, super slow. Let's increase the speed to something a little bit bigger, maybe 20. Fantastic. So let's expand on this parent-child relationship. Let's take another primitive and connect it to the sphere that we have here. I'll type in primitive. I will connect it to the sphere. Obviously, now they are both in the same 0, 0 position. So the newly made one, I will just offset it a little bit to the top. And for the clarity, I'll make it into a box so we can just read it a little bit better. And now perhaps we could use, say, math modifier to drive its position y. So I'll add a math modifier. And I will connect it to the position y. There we go. It's a little bit fast and it's a little bit big. So you see how in no time I can start building repetitive and interesting animations just by adding primitives, nulls, and using continuous or math modifiers. Now imagine keyframing those two values time and time again for 30 seconds. It will become very, very laborious, very, very fast. And then if you need to change speed of it, that becomes a headache. And here, all you have to do is just change the slider's value. I really like modifiers. So before we move on to a bit more complex setup, let me show you a very practical way to use null and let's say a primitive and continuous modifier. I find myself using this type of rig all the time. So what I'm going to do, I'm going to add a 3D primitive. I will keep it in the center of the graph and I will make it into a box. And now I will add a null connected to the root and I will add a camera. Now I could connect camera to the root, but I will choose to connect it to the null, just like we connected a 3D primitive in the previous example. So now I'm going to grab this camera and I'm going to offset it a little bit backwards so it actually can see this box. And if I hit 0, now I'm in the active rendering camera. Fantastic. So why did I connect it through the null? Well, basically this null now becomes a gimbal that I can rotate and this camera will turn around and around this 3D model. So let's add a continuous modifier and connect it to rotation heading property. So if I hit 0 now, I'm actually rotating around this 3D object. So not only you can connect 3D objects, you can actually connect various tools and various nodes and notch, cameras included. So this is just a great way to set up a 360 camera rotation around a specific 3D model of your choice. Okay, so with that said, let's move on to the modifier start. Here we have some 3D elements and some textures, and we will modify and animate a couple of things, and it will probably gonna end up looking something close to this. So, first of all, what I would like to do here is make sure that the tarmac is actually moving together with these fellas walking. As you see, it's static, so how do we go about that? First of all, we need to navigate and find that in a node graph. We have some post effects here, I see. We have a couple of background elements, a lighting rig, a camera with a null, that's great. And here are 4 quads that are using material, and that material happens to be the one that we're looking for. So in order to drive the motion of this tarmac, I'm gonna go to the material and I'm gonna slide a little bit further to the UV bracket of this material. And I see here that I have UV offset X and I have UV offset Y. And since the material in itself is tiled or repetitive, I can just grab this property and apply a continuous modifier, and it will animate giving an impression that these guys are walking on the tarmac. Now, obviously, I will want to go the negative way for it to follow the correct direction. So I'll put it back to 0. I'll grab a continuous modifier, and now I will connect it to the UV offset Y property. It is working. It's a little bit too fast and it's going the wrong direction. So in order for this to go to the right direction, instead of the add, I'm going to go for subtract. So that's already better. And I think I really need to reduce the speed. There we go. That looks more interesting already. So what else can we animate here? I've mentioned that there's a camera with a null. I think it would be fun to add a little bit of a shake to this camera. So how about we put a matte modifier in a position Y? There we go. It's working. It's a little bit too aggressive, so I'm going to reduce the speed. And I think I want to change it to a purling noise. There we go. Maybe the scale could be smaller as well. So that's a small little subtle animation there. That works really well. I think I'm going to make a copy of this matte modifier and I'm going to apply it on a position Z as well. Now, I don't want these two animations to be exactly the same. So what I can do, I can offset them in time. So I'm going to set a 0.5 time offset. There we go. This already looks a little bit more dynamic. And you see, I have the whole element here in the back, so I could probably do something with it as well. So if I click on it and press F1, I'm navigating to exactly where it is in the node graph. And what I want to do is perhaps rotate its pitch, and I want this to happen continuously. So this is a great place for continuous modifier. There we go. Again, quite slow. So I'm going to increase the speed to something like 20. And instead of add, I'm going to go to subtract. So it goes the opposite way. Not bad. Can I do something more with this? I see I have these arrows that are childed from the torus. What if I alter their heading property? So let's grab another continuous modifier. And I will connect it to the heading property. I think I'm going to use the same continuous modifier on the other arrow as well. So it's going to go to the same property. I think it's working. It's just really slow. So let's increase the speed. Yeah, and it's rotating. Fantastic. Maybe a little bit faster still. And I see that the arrows has a couple of child nodes of their own, and that would be box. So what can I do here? I can drive the position Y with the matte modifier here. So I'm going to grab that. Position Y. And I will use the very same matte modifier to drive the position Y of this box as well. It's a little bit aggressive. I think the scale could be much, much smaller. And of course, animations could be slower too. There we go. So if I go to the active rendering camera, I see that element there having a bit of animation in the background too. So let's build out something more. We are already familiar with the image plane and the fact that we can connect it to the root. In fact, we can connect image plane to the camera as well. So why am I connecting image plane to the camera? Well, basically, I want this image plane to be static in the scene at all times and just look straight ahead at the scene. Should I connect it to the root of the scene? I would have to then position it so it would be looking at the camera, and that becomes a little bit tedious, and as you see, it's then moving together with all of the elements, and that's not what I'm after. So I'll reset it and I'll connect it to the camera, and I'll make sure that I see it through the camera. And in order to do that, I just have to push it on a position Z in a positive direction. There we go. So now I'm gonna find something to use with this image plane. Perhaps the UI code, this little PNG right here. So I'll pipe it to the first input. Great, and I do want this to be scaled correctly, and I want to look at the scale X for the 16:9 value. Great, and I think it should be in additive mode. That's much better. So I'll just make sure that it fills the whole canvas. There we are. So now we have a little GUI element that we're overlaying on the camera view. One more thing that we could do is make sure that it's not obstructing the center. And we can do that by adding a gradient here in the alpha image input. So I'm adding a gradient. I will shape it a little bit. I do want this to be 1920 by 1080. Great, and I guess it could be radial. And the inner range could be a little bit bigger, so something like 0.6. And it does exactly the opposite of what I wanted, but I can always invert it. So here is a property for inversion in a gradient. And this is more like what I was looking for. Fantastic. So the next thing I'm going to do, I'm going to add a little bit of animation to this element. I'm going to go for Chroma Glitch. So if I connect that to the UI code, yeah, I see it's working. I'm going to go for no split and hold frame. And maybe I'll slow it down a little bit. Now, I do like it, but I think it's a little bit too intrusive. It's happening too often. What I want is this glitch to happen a little bit more random. And that is exactly where things get a bit more complicated with the modifiers. I can build that random trigger using a math modifier and condition modifier. And I'm going to use those two nodes to drive the active property of the post effect. So basically, at some point it will be just active, and at some point it will be just disabled. I will add a math modifier, and I will add a condition modifier. So my goal now is to connect those two and make a condition that every once in a while this Chroma Glitch is turned on. So how do I go about that? First of all, in a math modifier, I should probably choose a math function that spits random noise. And that random noise probably should be a bit bigger, so maybe a scale of 10. And it is a rather fast one, so I'm going to slow it down immensely. So now this node is spitting information from 0 to 10 randomly. That's great. And now I want to build a condition saying that anytime you receive a value which is greater than 8, that will be our threshold, you should send out a value of 1. And that value of 1 will be triggering the post effect. So let's connect the math modifier to the condition modifier. So now the condition modifier is receiving data from math and is double checking that if it's smaller or bigger than 8, and if it's bigger than 8, then it itself sends value of 1. There you go. And yeah, there we go. We have this random glitch effect now happening. To illustrate this a little bit better, I will add a tint post effect, and I'm going to apply it with the same condition modifier just so we see it better. There we go. Anytime we're above 8, it's sending out a signal and triggering these post effects. Okay, so let's push things a little bit further still. I see I have another scene available for me. So that's the real-time scene start and real-time scene finish. I think it's a good time for us to try out a little bit more complex setup with not only modifiers, but with a tiniest bit of a logics. So we're gonna build these lightning effects. Let's get that done. So first of all, I want to find a 3D mesh. There we go. So it's going to be lightning.c4d. I will press on this little drop down here and I'm going to choose the inner node. So with that done, I'll connect it to the root. And here is the element that I'm looking for. So I'll make it bigger. And what else can I do? Well, for this to be convincing, I should probably add an area light to the end of it, just so it actually lights up something. So there's the area light, and I will push it upwards. And let's turn it so it's looking down, and I'll make it really bright. There we go, something like 10, for instance. I don't need to see the visible surface, so I'll just turn that off. And now I can rotate this lightning. Cool, so if I turn it on and off now, I see that it's taking effect. I probably should add a material here, because I do want this lightning to be, let's say, bluish. And I will make it emissive too, so it's consistently lit up. I don't need this emissiveness to light the scene, so I'll just take that off. And another thing I could do is add a glow post effect, connect it to the root, and I just want to use it with this lightning. So I'm connecting it to the second input, and I am taking on apply to opaque objects only. There we go. So now this lightning is more or less ready. And another thing I want to do, I want to have a copy of this setup. So now I'm going to make a copy of this 3D object, connect it to the root, and I will offset it to another side and maybe place it somewhere else. There we go. And I want the same thing happening with the material. So I'll reuse the same one. And I do want the area light, so I'll copy and paste it there. And let's apply the glow to this as well. Cool. So my next task is to make sure that these lightning bolts don't linger there for too long and light up one after the other. So how would I do that? I can use a select child node for that. I think it's going to be easier to explain it in a simpler setup. So I'm going to roll back to the blank and let me show you what the select child node does. So I'm going to make some primitives now. So this is my primitive 1. And this is my primitive 2. And this is my primitive 3. What I want is to make sure that one of those is always on screen, but not all of them at once. So I can pipe them all through select child node. And in the select child node, I have an index. Which child should be rendered on screen? And it goes through numeric values from 0 to 1 to 2. And I can drive all of this with something like, say, math modifier. So if I put it back to the 0 state, I can grab a math modifier and connect it to the child index. And I will set it to a scale of, let's say, 3, and I will make it into a random noise. Again, I will reduce the speed quite significantly. And here we are. We are randomly rendering one of the spheres that are childed to select child node. So we'll do exactly the same thing right here in our example. So we're going to bring in a select child node, connect it to the root, and pipe those two lightnings through it. Great. So now it's going to be one or the other. And we could probably add one more numeric value so it wouldn't render anything on screen. So let's add a math modifier. Let's do the same thing. Choose a random noise, reduce the speed significantly, and connect it to the select child. And let's increase the scale to, say, 2. Maybe it could be a little bit faster. But there we are. So this is our logic setup for lightning. Now, before we move on to another chapter, there's one more thing that I would probably like to animate here. These light strings, they all have emissive materials. What if we put the matte modifier so they actually shimmer a little bit? So let's see. What if we animate the brightness property? I'm going to bring this down a little bit less to a minimum state. Let's say 0.5. And now I'm going to grab a matte modifier. I'm going to set it to the random noise. I'm going to set it to the Perlin noise, and I'm going to slow it down. And I will connect it to the emissive material number 1 and to the brightness. Let's increase the scale to 3 so it would be really visible. Yeah, I see it's shimmering, that's great, but it sometimes goes to complete black. And that is because sometimes we're dipping beneath the 0 to -3, so it's oscillating from 3 to -3. I don't want that. I'm gonna tick on use absolute value, so it never goes below 0. Yeah, that looks much better. So I'll apply the same matte modifier with these two materials too. However, I'll make copies. And I will offset them in time. So time offset 0. Let's say 5. And then another copy. Time offset 0.7. I want them to look a little bit more random so they wouldn't blink at the same time. So we're barely scratching the surface of what modifiers can do. As I mentioned, there's a lot of them to choose from. If you want to delve a little bit deeper and learn a little bit more about them, do check out our stream about modifiers. Now, this stream is based on a previous Notch version, but all of the information given there is still valid and applicable for 1.0. And once you're done and ready, do meet me in the next chapter where we're going to talk about particles.